Okay, so for a prime, I got 2 times square root of 1 minus x squared over 4. And then plus 2x times 1 half times 1 minus x squared minus 4. Or over 4, yeah. To the power of negative 1 half times x over 2. Oh, negative. Okay, that's it. Um,
Sorry, I was muted for a second there. Very good. Um, is this something you're comfortable graphing, finding the zeros?
I can just graph on my calculator, right?
Yes. It's just a lot of work to put in and easy to make mistakes.
Yeah, I feel pretty confident doing that.
Okay. There is nothing more to do on that problem then, except like once you find the x value, um, you you would then put that back into the area equation.
The regular one, right? Not the derivative.
Yeah, you then find the area. Yeah.
Okay. Okay.
And you got to find x and y also because
For
it
that
says
one. Okay.
dimensions. Is that clear?
Yeah.
Okay. All right. So the next problem, number 19. All right. A ranch has two adjacent rectangular corrals with a total area of 1750 feet. Okay. Now, unlike the picture here, I would recommend sticking with horizontals being x's and verticals being y's,
Okay.
which it'll be slightly different than what you'll see in this other paper. You'll get to the same answer, but that would be my recommendation.
Okay.
Now the area, what dimensions? All right, so the area, they're giving the area, they're telling you the area is 1750.
Hmm.
The area is 2x times y. So 1750 equals 2xy like that.
Okay.
Is that okay so far?
Yes.
And then you're trying to minimize the amount of fencing. So you're going to minimize the fencing, which is 4x plus 3y.
Okay. And then we use the 1750 equation to solve for y, right?
I recommend solving for y. Yeah, that would be
Okay.
that would be best. This is 1750 over 2x, which is 875 over x.
Okay. And then
So
we find
again,
the derivative,
sorry,
right?
question? Sorry.
We find the derivative, right, of that?
Yep, four, yeah, and 4x plus 20, 26, 25 over x. And so you set this equal to 0.
Um wait.
And you can use a calculator at this point. You can actually solve it if you want.
Okay. So minus 2625. Um, and I can bring the x up, right? So it's like -2.
I would just would like treat this like 4 equals 2625 over x squared and then cross multiply.
Okay, so 4 equals.
So you get 4x squared equals 2625.
So x equals 25.62.
Okay.
25.62, yeah, okay.
Yeah, so, I mean, sounds good. And then you would put that back in to find y into this equation.
Okay. So 875 divided by 34.15.
Okay. And then you put it back into the area equation to get, whatever. I'm sorry. So no, no. You put that back into the fencing equation to find the minimum fencing.
Wait, why am I plugging into the area equation?
You're not. I misspoke. You're the fencing equations, which is what it goes back into.
Oh, okay.
You know, 4 times that x value plus 3 times that y value.
Okay. And I think, okay, never mind.
Uh, please, did I? Yeah,
No,
is
no,
it
no, no.
clear?
Yeah, no, I get it. Don't worry.
All right. A couple of like small points here is that you want to include units. So like, yeah, this was in feet. Y is in feet. The fencing is also in feet. Just make sure you got units down.
Okay.
Um, what's another thought here? Okay, we're not actually proving that this value is the minimum. And I don't know if your instructor wants that. Like
For the x?
normally, yeah, like normally you're supposed to show that
Oh,
that critical
yeah.
point
We
is
just plug it into the calculator. And I would just do like 25 and 26.
sure, but that's like missing from all this. So my point is like I don't know. It's up to you if you want to do that or not.
Well, if I did do that, would I plug it into the area or the fencing equation?
The derivative, like
Of,
like the you it's the derivative test f prime.
okay.
So in this case, since it's a minimum, we would hopefully get this.
Yeah.
Is that okay?
Yeah.
Okay. May I have just give me 30 seconds here to um okay. Next problem I see is 15. Does that
Yeah.
look right to you?
Yeah.
Y equals 4x squared plus maybe 3 power of 8 over 3x minus 5 to the power of 10, maybe?
Um, I think it's 4 squared. Oh, yeah, yeah, yeah. Four
Okay.
squared plus.
It gets really grainy when I zoom in.
Yeah, mine too.
Yeah. Okay. So this is a logarithmic differentiation problem. Otherwise, you're using quotient rule. And that's awful. So you take the natural log of both sides. Um, this becomes 8 natural log 4x squared plus 3 minus 10 natural log 3x minus 5. And then the derivative's pretty straightforward from here. The main thing to remember is that you're not done once you take the derivative on the right. You have to then take the derivative to the left and multiply both sides by y. So
Okay.
on it's 1 over y times y prime equals 8 times 4x squared plus 3 over 8x minus 10 times 1 over 3x minus 5. But you're not done here. You have to then multiply everything by y.
Yeah.
And it's easy to forget to do that. 30 over 3x minus 5. And so that y is the original.
Okay. Okay. I got that.
Okay. 16. Why don't you try working through this one on your own here? It's like the previous one. You're going to take the natural log of both sides, and then it's a product rule problem. See if you have
Okay.
any questions about that.
Okay. For y prime, I got cosine x times ln cosine x plus sine of x um, times negative tangent of x times cosine x to the power of sine x.
You mean all of it times that?
Yeah.
Yeah. Okay. Any like questions on how to do that?
No.
All right. Um, all right, so next problem. 17. This is a chain rule problem. 5. I would probably rewrite it like this. 2x. I think that's a squared inside there.
Let me look.
It's really hard to tell. And the student didn't do it right, so it's also further hard to tell.
Wait, 5. What number are you looking at? 17?
17. Yeah. It's a square root, but inside
Oh,
square, I can't
okay.
tell if it's 2x cubed or I really can't. Couldn't tell you what it is. So um,
Um, I think it's 2, but
yeah.
yeah, I'm not too
Okay.
sure.
So the overarching rule here is that it's an a to the x derivative, but it's a chain rule with, you know, this is an outside function. After you do this one, then you have an inside
Yeah.
function. Do you want to try giving this one?
Yeah. Okay. So I did ln of 5 times 1/2 times 2x squared minus 1 to the power of negative 1/2 times 4x. And that's it.
Anything else?
No.
Okay, so you're missing you're missing the original. The derivative of a to x is always itself.
Okay.
Then everything else is correct.
Okay. Okay. Okay.
Any questions on that? Do you
Nope.
want to do, or do you think it's gonna be just like that? Um,
I'm pretty sure it's the same exact problem.
okay,
And if it's not the same exact problem, it's gonna be like the same exact thing, just different numbers.
all right. All right, let's keep going here.
Okay.
All right, so sorry, I can't. They keep the updates always different. All right, second derivative of this other thing here, 18. So we got y equals 2e to the cosine x. All right, why don't you try taking a first derivative of that for us, please?
Okay. Okay, so isn't it just 2e to the cosine x times negative sine x?
Yes.
Okay.
So then there is a good reason to simplify when you're reusing the derivative, because now it's a product rule for the second derivative.
Okay. Um. Okay. Okay, I got negative 2 cosine x.
Right.
And then or times e to the cosine x
Good.
plus negative 2 sine x and then times e cosine x times negative sine x.
Good. All right. That works. All right. Any questions on that or concerns?
No, I'm good on that. Okay.
Parallel tangent lines. All right. So another 17. Was the numbering updated? Well, I guess you'll find out tomorrow.
Yeah, I don't know.
All right. So in this problem, 3e to the 2x g of x equals 6x squared. You have to first be able to take a derivative. It asks about the tangent lines, so you got to take a derivative of both. So could you do that for us, please?
Yeah. Okay, so 3 or can I so 6e to the 2x, can I do that?
Yep. Perfect.
Okay. And then g prime of x equals 12x.
Good. So it asks where the tangent lines are parallel,
Okay.
and that's where they have the same slope. That's where the derivatives are equal. There's no way to do this by hand that you know of,
Okay.
or anybody in this class would know. So you're going to use your calculator to find the intersection.
Okay.
And so the graph of E looks like that. There might be two, it might be one. I don't know. I don't know. You'll have to investigate that.
What number is it? Where is it supposed to intersect?
Do you want me to get the values? Let me graph it and I'll tell you.
Well, I tried graphing and it's not intersecting. Oh, it's because I.
Uh, that may be the case. They may never intersect. Yeah. So there's nowhere.
Okay.
Oh, you know why? Because I couldn't read the problem, and that's the wrong derivative. It's there it
Oh,
is. And that's one of the issues with what we're doing here. So it does only have one intersection point.
okay. Hold on. Okay, I see it now.
All right.
Okay.
So I'm looking on the back side of this page where it says find all the relative extrema and absolute extrema of f of x equals 2x minus 3x to the 2/3 power on the
Um.
interval -1 to 3. Any
Okay.
questions on that?
X minus 3x.
So that's this, or is that what you see? I should be asking you, is that what you see? Because I got great
2x.
eyes, but this is such a low.
Yeah, that's what I see too.
Okay, so the first thing is you evaluate at the endpoint points.
Okay.
So you got 2 times -1 minus 3 times -1 to 2/3 power. You'll want to evaluate that um, in your calculator.
Um. 2/3. Um. Okay. Okay, so for the first one, I got -5.
I agree.
And then second one, I get negative 0.24. That doesn't
Yes,
look right.
that's correct.
Oh, it is.
Yes.
Okay. And what do I do
So
from there?
so now you have to take a derivative. So
Okay.
derivative of x 2 minus x to the -1/3 power. Set it equal to 0. Now there's two things you're looking for. The first is where it literally does equal 0. The second is where it's undefined. It's undefined because you're dividing by 0 when x is 0. Sorry, I didn't mean to put 0 in there when x. But when this is 0, the derivative is undefined. Graphically, that's a cusp. Let me show that here. So what I'm saying is that that's also a place to look for, and then you'll find this other critical point. So the critical point is when the derivative equals 0, which is at x equals 1,
Okay.
which
Wait,
means I
hold
didn't.
on.
Why didn't I do that? I made a
Isn't
mistake. There's
it
some sort of,
two? Wait, isn't the
yeah,
derivative 2x?
yes.
Okay.
Yeah, there's 2 there. Thank you.
Okay. And then I'm making that equal to 0. So 2 minus 2 over. Wait, why am I making it a radical? Why am I making the x radical?
You don't have to. I was just trying to show you how it like that's why it goes to the bottom. The undefined is when x equals 0. That's when the derivative is undefined because you're dividing by 0. They're trying to show it in another format.
Okay. So it's undefined because x is in the denominator, right? And it could equal 0.
Yeah, exactly.
Okay.
All right, so then you have to then go back to the original function and try it. You have to value it at 0 and at 1. Those are both in the interval from -1 to 3. That's why you try them.
Wait, where'd you get 1 from? Sorry.
Setting the derivative equal to 0 and solving
Oh,
for x.
okay.
It's two things. Critical point where the tangent line, horizontal tangent line, the derivative is equal to 0, or where it's undefined.
Okay. So then f equals 0 equals. So you have a wait, positive to negative. You have a max when x equals, wait, nope.
Let me show you the graph of this so we can just talk about each point and what it
Okay.
means. Sorry, I just grab a snip of this. All right. So we had the endpoint. So
Okay.
we have these points here. So this is the absolute min. This point right here is the absolute max. This is a relative min, and this is a relative max.
Okay.
So this was f of -2, f of 0, f of 1, f of 3.
Okay.
So what your teacher really wants you to do is create a little sketch like this so you can know what each of those is, rather than having to use the derivative test, which does work, always works.
And how would I do the derivative test?
You're
Is that
supposed
what
to, draw a little number line, -1 to 3, put in 0 and 1 and test points, and you'd find that increasing, decreasing, increasing.
okay. So there's a max at 0, like you said. Okay, that's the cusp.
Yes.
And then a minimum at 1. Okay.
It's a lot easier to do with the graph.
Yeah.
And like what you can do on your window is you can limit it to -1 to 3 on your X min and X max. That way you won't have like you'll just be looking at just like I am here. It's like how you cut it off.
Okay. And like whenever it's asking for me to find relative max and mins, do I have to put the coordinate or can I just put at x equals 1, do you think?
I'm reading the answer here. See if your instructor accepted the best answer is to say min of -1 at x equals 1. Like that's the full answer.
Okay.
know, is that fair?
Yeah. Okay. I
What I
think I
can't
understand.
tell in the next figure is what, like, which one was the original and which one was the, I don't even know what the student was doing here, but let me
I
try
think
this.
it looks like the solid, like there's two solid ones. Never mind. Um.
I'm gonna snip it in. I'm gonna draw what I think the teacher wanted
Okay.
or what they meant. So I know this is really grainy, but I'll do it in blue. So I believe this is the only, like everything else that is not, you want to try to ignore, you
Yeah.
can. This is F prime. So what I would do is draw a little number line here. So we got -5, -1, 3, and 5. And for the derivative, if it's positive, right? Like this is positive, negative, positive, positive, positive.
Okay.
Because you're literally just looking like, is it above the x-axis or below?
Okay.
So we're looking for where it has a relative min. A relative min, that's part A. It
Yeah.
has to go from minus to plus. So that's at x equals -1.
Okay. I think. Wait. Relative min.
Minus to
Because it goes
plus.
negative. Because it goes. Wait. Because it goes negative positive, right?
Uh, so remember, you're looking at the derivative, so it's different than the original function. We're talking about a min of the original function.
Um.
So like this is not a min.
Yeah.
I mean,
It's a
I mean,
minimum whenever it crosses the
yes,
x-axis, right?
as long as it goes from minus to plus. Because
Okay.
when it crossed here, that's not, that's the max. And that's what B asks.
Okay. So.
No, sorry, -5. And so there's way you're the student way too many words. Like this is sufficient.
Okay.
You don't need to dress it up. Teachers don't want to read this unless your teacher says otherwise.
Minus to
Okay.
positive. Yeah, because just writing negative to positive is justifying, right?
I feel like it is, especially in this
Okay.
context. You could say, you know, decreasing to increasing. I mean, you want to follow the notation the teacher's been using all semester.
Okay. It's pretty much that. I don't like. We don't ever write
Okay.
like a lot.
All right. Now, C asks where the second derivative is less than 0. Um, that's concave down. That's great, but it's wherever the first derivative, f prime of x, is decreasing,
Okay.
because the second derivative is the slope of the first derivative, so it has a negative slope when it's decreasing. So where is the graph going down and to the right? You can
Negative
see it goes
five.
down,
Yeah.
goes in this whole region here from -7 to -3. That's region number 1. And then 3 to 5.
Okay. And final values. And that's all I have to write.
Yeah, I mean, like this is kind of key. I mean, if you give the answer with no justification, maybe it's acceptable. I don't know.
After decreasing. Okay. -7, -3. Comma.
Absolute maximum. So the next one's asking where F is an absolute max. A little out
Um,
of scope for you guys. It has to do with the area under the curve.
okay.
But I don't think you would know enough for that. I don't know how you guys are supposed to know this much. But it's at 7,
Okay.
but I don't know how you would know that. And I'm afraid to give you an answer here that would maybe imply you had gotten some outside help.
Um, I don't know.
Or do you want more explanation?
um, maybe just because I think it's on the test. So,
Okay. So this is beyond where you're at in this course. That's why I'm being clear how I explain this.
okay.
So the idea is that there's an area under the curve here that is positive, an area under the curve here that is negative. They effectively cancel each other out.
Okay.
And so think of this as like a zero, like starting out at basically a zero here. And then it's this area is contributing positively, and then this area down here is contributing positively. So that is why it occurs at 7, because it's getting bigger and bigger and bigger, and then bigger and bigger.
Okay. That makes enough sense. Okay.
All right. So we're kind of running out of time here. Be able to get everything done on this 13. I can't really read the function.
We do 14 instead, actually.
Sure.
Okay.
All right, 14. F of x or s, I guess it's x equals 1/2 x minus sine x,
Yeah.
0 to 2 pi. Okay, so you find the derivative, 1/2 minus cosine x, set it equal to 0. This is where you need to remember your unit circle. Where does cosine x equals 1/2? Cosine's the x value, so it's 1/2 there and there.
Okay.
Um, if you have a calculator, oh, no calculator, you would know that it's pi over 3 to this one, and then it's minus pi over 3. But if you got to go the other direction, it's 5 pi over 3. Somehow you have to get those answers. And
Okay.
then you put those on a number line from 0 to 2 pi,
Power 3. Okay.
and you have to test those in the derivative. And that could be challenging too,
Okay.
because you got to know, like, what do I test? What's in the middle here? Like pi is in the middle. Um, because because cosine alternates and it's by itself, you could kind of just, if you get one, you could alternate the signs,
Okay.
but that only works in this very specific case.
Okay.
So I don't, I mean, that's, or you could say, okay, I want to do pi over 6. I'm going to do 11 pi over 6.
Okay.
That could be challenging, really challenging here, but that's
Mhm.
that's kind of what the teacher is looking for there. Uh, what did this other student do? I guess they did make a sign chart. Looks really cluttered though. So,
Yeah.
uh, so in this first interval, like the way to do it here is that cosine is actually much bigger than 1/2 leading up to pi over 3. So when you take like 1/2 minus a number bigger than 1/2, this one ends up being negative, positive, and negative. Um, yeah, and then you can get your relative mins and
Okay.
maxes.
Okay. Just by plugging those in.
Yeah, if you're allowed to use a calculator. It says no calculator, but maybe that was a mistake. Pretty
maybe he'll
tough
be
for
able to.
most. Yeah,
Yeah, and I'll just look over that problem again and see what he did. And if anything, I could call him. So,
yeah, phone a friend.
yeah.
Um,
Well,
right. Got a couple minutes left. Anything else you'd like to cover today?
no, that's it. Thank you very much.
All right. Let me go ahead and stop the recording.